The next model we want to talk about is the Sashimi model. And this model sort of was built off of an idea that maybe we didn't think about at first, but when you think about it, it's very practical. And that is that in each one of these phases, we don't necessarily have the exact same engineers. So a lot of times we are under the assumption that maybe we have one or two engineers and they're going to do the requirements and then the design and then the implementation and the testing and the deployment and the maintenance. But usually what we have is, especially in larger companies, is we have specific engineers that do things like the requirements, that do things like the design, whether it be the back end or the front end, that we have implementation engineers, we have testing engineers, we have deployment and maintenance engineers. And because of all of this, we have this issue where if we do it step by step, like in the previous examples with the V model and the waterfall model, all of these engineers down here have to wait until the previous step is completed. And then once the previous step is completed, all the engineers on the top are waiting once again. So you get this sort of area where a lot of your workforce is sitting around waiting for other workforce to complete their tasks. And so with the sashimi model, we have the ability to draw these lines down it. So basically we cut it up. So it's the sashimi model. If you've ever had sashimi, it's a dish of basically raw fish cut up, and it's usually laid out on top of one another like so, usually over one another. And that's why this is the sashimi model, is because you have these pieces all laid on top of each other, and then you're basically cutting down to different categories here. So if we go ahead and we can draw these basically slices here. And what this is these are the different phases of development. And we would, of course, maybe make these phases, like maybe we have 1 month objectives or 2 month objectives. But essentially what we're doing is we're doing a little bit of everything in each one of these phases. So with the requirements, and in this graph, we're going this way. So time, as we go through time, we head this way. So when we start, we start with the requirements, the design, and maybe a little implementation, maybe a little testing here. And then in the next phase, we're still working on the requirements and the design, and now a lot of the implementation, but we're also getting our testing and our deployment and our maintenance engineers involved. The deployment engineers are figuring out the best way to deploy it. The maintenance are maybe creating systems. Maybe we're putting out test models or betas that these guys are working on as well. And we keep doing this with each step. So in the next step over here, what we'd have is we're now doing everything. We're slicing all of it at the same time. And then down here, we slowly taper off until we're just in the maintenance phase. And again, this helps us because it allows different disciplines to begin working quicker. It also shortens the development time. Instead of having to wait, let's say if it was, up here 2 weeks, so this is the amount of weeks, 2, 3, 4, 5, 6, and 7 weeks for each one of these tasks. So this task is 7 weeks to complete. This task would take 5 weeks. Imagine if we did these one at a time. It would be 2 plus 3 plus 4 plus 5 plus 6 plus 7. Or what we can do is we work on them all a little bit, and we all are basically starting them almost within the same week. So the total time will probably come out to somewhere around 7 or 8 weeks instead of adding all of these together. And that's a lot of a time save there. Now, the issue that we might have with this is it may result in error and redesign. What this means is, just like with the waterfall model, if we find an error at some point, we're going to have to go all the way back. And the error is more prevalent in this situation. And that's because we haven't finished the requirements or the design yet by the time we're implementing and testing, which means over here, we might find something that needs to be completely reworked, and everything back to maybe like this over here needs to be reworked. And because of that, all of the work, we don't only just have to rework the requirements, we now have to rework everything that the requirements touched. So everything down here, we're gonna have to rework. So it sort of opens us up to this potential where if we don't think about this, and if we are a little bit sloppy and have an error late, we're going to have to do a whole lot of reworking. And it can actually turn out that it'll make it slower to develop this way if we have those errors. But if we don't have those errors, we have great workforce utilization and efficiency, and we have really shortened the development time.